Oh, wait. Put that as our background.
Ba-dum-bum-bum. We chose chlorine.
The standard atomic.
Okay, here's standard atomic notation for chlorine. This number right here is called the atomic mass. This number right here is called the atomic number.
How do you bring this in front?
And this whole letter, C and L, is the symbol for chlorine.
Like carbon in there.
Symbol.
This is how to draw a Bohr-Rutherford diagram. To start, you need to know 3 pieces of information. These are called the subatomic particles, which are the protons, electrons, and neutrons. So, the protons are the same as the atomic number, so 17. There are the same amount of electrons as protons, so there's also 17. And now to find the number of neutrons, you need to subtract the atomic number from the mass number. So 36 minus 17 is 18. So now we know our 3 key pieces of information are: this is the nucleus, where the protons and the neutrons go. Next, we have another ring called an orbit, or shell, or an energy level. There are many of these orbits around the nucleus, and they hold the electrons. The first orbit can only hold 2 electrons. The second and third can hold 8. So now we fill in our subatomic particles into the diagram. So the number of protons is 17, and the number of neutrons is 18. Then we draw our electrons, which go in the outer orbits. And since only 2 fit on the first orbit, we draw 2 electrons. Then we move on to the second orbit, which, as you know, holds 8. We go in order by 1. So we go 1 by 1 down the orbit. So we go, there's 2, so we need 3, 4, 5, 6, 7, 8, 9, 10. So that's only 10 out of 17 electrons. So we need to keep going to the next orbit, which is the outermost one right now, which is called the valence orbit. So we go now and we add 10, 11, 12, 13, 14, 15, 16, 17. Now we have our successful Bohr-Rutherford diagram with our subatomic particles all on here. So we have our protons and neutrons, which are in the nucleus. And all our electrons divided evenly around in different orbits.
Recording. So here is our last orbit, and in this orbit we have 7 electrons. Right here. Those are called valence electrons. See, there's 7 on this orbit, the last valence orbit or valence shell. And then there's exact same number of valence electrons.
Just re-record there.
Okay, now we are going to draw electron dot diagrams. remember in our last slide when we were drawing the Bohr-Rutherford diagrams, we now need to look at the valence electrons, which is on the last orbit. To draw them to show on a dot diagram, we draw dots in quadrants. So here's one quadrant, there's another, and there's 4. Okay, so dot diagrams are representatives of the valence electrons. They show how many valence electrons are in this atom?
Yeah.
Okay, in this atom. So, here is 1, 2, remember we have 7, 3, 4,
Cancel that. Keep going.
5, 6, 7. So the number of dots on each dot diagram are the same number and the exact same place as the valence shell and the number of valence electrons in the Bohr-Rutherford diagram. So, this is how you draw an atomic dot diagram, or electron dot diagram, sorry.
This presentation was brought to you by Smrtka and
Marley.
ta-da!